Hello everyone, this is Jivika Kancharla and I'll be explaining you guys the solving of question 5 of homework 2 of the course Probability and Stochastic Processes. So in the question 5, let's go to the question first. The customer flow at a grocery store can be viewed as a Poisson process, that is, probability that n number of customers arrival in 0, t equal to k can be equated to e power minus lambda t into lambda t power k by k factorial. Suppose the probability that in 2 minutes at least one customer arrives equal to 0.3, we are asked to find the lambda value, that is this value. So let's look at the solving of this one. So at a grocery store, customer flow can be viewed as a Poisson process as probability that hash, that is n customers arrival in 0, t is equal to k, which is equal to e power minus lambda t into lambda t power k by k factorial. We are supposed to calculate the value of lambda, and it's also given that probability that at least one customer arrives in 2 minutes is equal to 0.3. Now let's calculate lambda. That is, we know that probability of at least one customer arrives in 2 minutes is equal to 0.3, which is equal to 1 minus probability that no customer arrives in 2 minutes. Therefore, the probability that no customer arrives in 2 minutes will be equal to 0.7. Now, let's calculate that the probability of customers arrival in 0, 2 minutes is equal to 0. That is, t is equal to 2 and k is equal to 0. Now let's substitute those values into this. Since we know that the answer is equal to 0.7, we will be equating that to 0.7 in order to calculate the value of lambda. Therefore, e power minus 2 lambda is equal to 7. Now when we take e that side, it becomes a ln. Therefore, lambda is equal to minus of ln 0.7 by 2, which will be equal to 0.1783. Therefore, the value of lambda is 0.1783. Now, in the second part, he's asking us to find the probability that in 3 minutes no customer comes. The probability that in 3 minutes no customer comes can be calculated by using the Poisson formula, where t is equal to 3 and k is equal to 0, and we have calculated the lambda is equal to 0.1783. So now let's substitute the t value, k value and lambda value into the Poisson formula, that is probability that customers arrival in 0, 3 minutes is equal to 0 is equal to e power minus lambda 3 into 3 lambda power 0 by 0 factorial, that is e power minus 3 lambda. Now lambda is equal to 0.178 from the first part. When we substitute that, we will get an answer of 0.586. Therefore, the probability that in 3 minutes no customer comes is 0.586. Now find the probability that in 10 minutes at least 2 customers will arrive. Therefore, probability that in 10 minutes at least 2 customers will arrive is equal to 1 minus p of no customer arrives minus p of at least one customer arrives, which is equal to 1 minus probability, that is, we will use the Poisson formula here, that customer arrivals in 0, 10 is equal to 0 minus customer arrival in 0, 10 is equal to 1. When we substitute that we substitute the t, k and lambda values, we will get that 1 minus e power minus 10 into 0.178 into 1 plus 1.78 will be equal to 0.531. Therefore, probability that in 10 minutes at least 2 customers will arrive is 0.531. Now let's go to the fourth question, where we are supposed to find the probability that in 1 minute exactly, that is, only one customer will arrive. We can calculate that using probability in 1 minute exactly one customer arrives is equal to, here the value of k becomes 1. Therefore, substituting it in the Poisson formula, probability that n customers will arrive in 0, 1 minute, that is t is equal to 1, is equal to 1. When we substitute the t, k and lambda, which we calculated from here once again, into the Poisson formula, that is e power minus lambda, since t is equal to 1 it will be lambda by lambda power k, which by 1 factorial. Since all of these values will be 1, we know that we'll get lambda into e power minus lambda, which is 0.178 into e power minus 0.178, which is 0.1489. Therefore, the probability that in 1 minute exactly one customer arrives is equal to 0.1489. This is the solving for the fifth question.